3 over 2. That's the value of x. But we need to get the what? The value of what now? Y. We've gotten the minimum. We've gotten the maximum. Now remaining the point of inflection. Next second derivative equals to 0. We've gotten our x. Put it into the main question, the main function. We got the value of y. So to get y for the inflation. To get y into f of x. So when you put 3 over 2 there, you're going to have y equals to 2 into 3 over 2 cubed minus 9 into 3 over 2 squared plus 12 into 3 over 2. If you use that your calculator, you can press everything once and you get your answer. And if you want to solve it too, you can. But from our solving, y equals to 9 over 2. Check with your calculator. Do you have that? Okay. So that will be our value for y. Now, to now conclude, the minimum points equals to the maximum points equals to the points of inflation equals to now our minimum points. Where do we have minimum? This one, right? When x is what? 2. When x is 2 means this one. So that's our minimum is 2, 4. Our maximum is when x is what? 1. That means our maximum is 1, 5. And our point of inflection for that one, x is what? 3 over 2. And y is what? 9 over 2. So this is the conclusion to this workings. The minimum, the maximum, and the point of inflection. So when you have question in that form, that's the steps to follow. First thing is to get the first derivative. Let derivative equals to 0 to get your x. Then put x into the function to get the 2 y's. Then second derivative, put x into the second derivative to know where is the minimum and maximum. So then if you are to get the point of inflection, let second derivative be equals to 0. You get the x. And after getting x, put it to the function again. You also get the y. Then you conclude. So the next topic is integration, but we're not starting that today. The all might be used for another class, so we will go straight to GET. And very soon our tutorial will end. Very soon our tutorial will end. So, which day? What day today? First reason is because of the venue that we are using. We've been having a chance to use it because, let me say, the seniors have not yet having their classes. But I was told they might use it today. Probably today till the end of the exam. That's for the first reason. Then second reason is for personal stuffs. But I can always have an online tutorial if you want. I have a venue that I can use for Spigot online, which will join YouTube channel. And if you are not online, like the one we are having now, you can go back to it later. It should be on the channel. Even though you are not currently there. After the class, you can go back to it. So maybe that was really good. Alright, bring that to our drawing materials. Question 1 is already on my platform. I'm sure you've seen that already. For set 2. So if you've not seen it, go and check it. Now, question 2 is what we'll be doing today. So bring that to the materials. Next 2 hours. So for the maths book I'm using Engineering Maths by K.A. Stroud mostly. Then I'm using the other mathematics by Bombay. So I combine the two. And at the same time I'm using a further mathematics textbook by NERDC, by Maths Association of Nigeria. So those are the ones I use for this class. Okay. So that's the minimum and maximum to this question. So getting it one after the other. So as we said, in orthographic projection, when you are given a diagram, the first thing to do is to know where will be your fronts, your sides, and your line. That will give you your sketch. Now, since this question, say the first one is determined, but the second one, that question is in, we have to get it in third angle projection. And our side view is from the right hand, from the left hand side. That means we are placing it to the left. Our front view is from the right, our plan is up. So my sketch, or the sketch we are going to work with, goes this way. So that's what I'm saying from the question. That's this and the name of that stuff is really with the distance of the sketch. Now, in orthography is but you need to be able to sketch the diagram. But at the end of the day, the diagram is not like a sketch. Now, to me, your sketch is on. Even before you start, it's not like actually because what you are seeing, you are already seeing it. You are already seeing it. It's not very good. But you have to see it. We have to be able to bring that to know where we are from, to side, these are the things that we very much do. Okay, so you have the diagram. I'm sure you can see that. You can see so from the plan, this on the top, you can see that left hand side. That one will only be seen from the top. Another part is the open line. That's what that indicates. Let me show you. This O here, you have it on diagram. This O here can only be seen from the top. That's why at the front, you indicate it as a broken line. At the plan also, we indicate it as a broken line. From the top, you can see I have double shot here, and that's what it looks like. Initially, it first looks like a straight edge, which you can see from top. Then you have a curve to your left, and so you can see it. You have a curve to your left and a curve to your right. That's why you have a double edge here. Then you have this part. Now, this part is for that circular stuff. No, that circle now. You can only see that circle at one place, that is a circle, which is at the plan. That's the circle. You can only see it from at the side, rather. You can only see it from the side, that is a circle. If you look at it from your front view, it's a rectangle. If you look at it from the plan, it's a rectangle. Next is this part. You can see this part, it's like a cuboid, right? So you can see it as a rectangle, like from that side. You see it here also as a rectangle from that side. But from the side view, you see this actual rectangle now, that big part from the left hand side, from the diagram. Then from the top, this is what you are going to see with these parts. But at the front is where you will see these parts with the circular holes. These circular holes cannot be seen from here, but only from here. Now these circular holes, I also represent them with a broken line at this place. Now you can see we have so many broken lines here. Why is it so? It's to show that some things are at the back that we cannot see from here. Now these two like this, is to indicate this one. If you look at the diagram, it's to indicate this place, this big one. that is at the back. It goes to the back like this, but you cannot see it. That's why we indicate the broken line all through. Then this other one, this one like this small one, is to indicate this elongation here, this one. Then we indicate the broken line for this because in the question we are told that this hole here, this space here, is like a C. I'm sure you can see it here. It goes to a particular depth, but not entirely. That's why it's only from here to here. It's the other small one that goes inwards. Say something now. That inwards one is a sentence. Does it go entirely to the end? This man. I know what's happening. So you may think you are doing the right thing. No. This is the question. The question says the figure shows a pictorial view of the site of the Spigot using third angle projection, so we know the plan will be up. That we draw the following views, includes hidden detail in all views. Now, front elevation. Looking in the direction of the arrow. Where is the arrow? From your right. Our front elevation is open. Now, plan view says projected from the front elevation. Plan view is always projected from the front, it's not from the side, which is this one. Projected means it must be the same length with what? With the front. That's what that statement is meant. Then the third statement says the end view is positioned to the right of the front elevation. Our end view is positioned. This is a projected from. Set positioned to the right of the front elevation. So the only thing that changes is that instead of this one being here, where is it going to be? It will be here. Should I raise it and draw it again? Yes. Who says this? So it means the side will not be to your left, but inside it will be to your right. But the question says the end view positioned to the right of the front view. Our side view is correct, yes, but it has to be at the right hand side.
So the side view is correct.
The side view is correct, yes. Because that's what you are seeing now. Okay, are you at the other? You are not at the other parts. Is where you have your front from here, you have your side from here. You now said you should position this to your right, to the right of the front elevation. That's the instruction. You follow the instruction. Let me sketch that. I'm not going to erase that one, but you should know that it's going to be here. So it's still the same thing. So it's still the same thing, but let's just place it there. So it's positioned to the right, not to the left. That's what the instruction is. So the end view is positioned to the right of the front elevation. is positioned to the right of the front elevation. So that means this one will be at the right hand side. That's the only correction. So when we are drawing this, we are going to place it there. So that means this space is not in here, but instead it should be there. It should be here. But I'll put my dimensions here as they are. Now, okay, 100 I get 205. Now, if you are into that, because we have 180 down there. We have 180 down. Now, up there says the box is what? Diameter of what? 50. That means radius is what? 25. That means from this center to this space is 25. 25 and 1 give us 205. That's why I get the total dimension to be 205. Then other things I add them. Let me just add the dimension. Later you can go through it to identify. So I'm writing that you don't identify them. I've not started. I've not finished the sketch. Because before you start before the placement of the margin lines, you have to calculate the dimensions you have to know where you will place it. What if you now place it now, and one of them is entering the title block? You now is this and start again. So calculate your dimensions first. This one, well, you know this one will be at the right hand side now, but I want to put the dimensions here. This one will be 76. This one will be 88. Up here, I have 22. Here, so okay. Here to here, I have 32. And from here to here, I have 44. This small one here, I have 2. Everything here is 50. The inside is 32. If the inside is 32, 50 times 32, that's 18. Divided by 2, that's 9. So I have 9 here and 9 here. Up next. This inside is 12. That inside is 12. I have the radius of each of these curves to be 6. Each of these curves. There are 4 curves that we have here. They are all 6. Okay? I have this place to be 25. I have this place to be 12. I have totally this place to be 64. I have from the midpoints upward to be 26. I have the total already, but I have from this place to this place to be 66. I have the diameter of this one to be 12. Now to this place, I have here to be 12. I have this place to be 32. I have totally here to be 66. I have so I have 12, I have 25, 12 and 25 then. What else? Okay, I have the diameters. I have the diameter of this one to be 50. Diameter of this one to be 32. And diameter of this one to be 12. Then from the plan, I have the diameter of this one to be 66. Now there's a curve here, and there's a curve here. So this curve and this curve gives us a circle. So that's the diameter of 48. And we get there, we see how we can draw it. What you have here is something like this. You have, it's just like you have a circle. Then from that circle, you triangle inside it. So that it now gives us this one. So that's what we have here. So we see how we can do that when we get there. Then what else? All those open lines, we can project them later to get what we have. Now this one is 32. This broken line, this small one here is 32. Right? Yes. That one is 32. 32 minus 44, that's 12. And this other one here is 12. Here is 12. What else? We get the other ones from this is, you know that this here is 32. Okay, so that's the sketch that I was able to get. All dimensions. So that's what we'll be drawing. But I said the only correction here is that this side view will be placed at the right hand side instead of the left. So this side view will be placed at the right hand side. So this two will be like this, and that. So these are sketch. Then we are going to get the construction. Your title block is where it is. So, I'm sure you have the sketch already. So we are now going to start. So from the sketch now, we are now going to start the construction. Now, in the placement of the diagram, your title block stays here. So let me just use the board to explain it better. So if your title block is here, I'll give you that the title block. So we have the other sheet for the drawing. Now, 76, 205, 270 is the space from here, from the title block to the borderline. 0 to 270 is what? 29 centimeters. 28. No, it must be the same. From your borderline to your title block here, what distance do you have from the drawing? 28. How do you go 25? It must be the same now, Abi. 28. Yeah. So that means 28. Okay. Anyways, we still take it forward, so we'll do that. Okay, dash. For some, it's 28. For some, it's 29. Do you know what? Paper and difference. So let's see how that. So for some, it's 29. For some, it's 28. So, 8 and 9. Well, now let's learn the graphical distance. We have 88, 76. 88 and 76 give us what? 164. Right? Now, do we have up to 164? Upward of the title block. So your brother line. What do you have? 18. Do you have 18 or 19? So you have 19. Faster than. So I don't know how to. Now from up downwards. You know that everything from up downwards is 36, right? Let's add. So let's say we have this. Let's add. So let's add the line downwards. Now from your, I'm sure you are with your T-square, with your board, or if it's also with your ruler. So from the borderline downwards, you know where your borderline is. So let's mark 9 centimeters down, 9 centimeters down, so that we can get our horizontal line. Nine centimeters down and 9 centimeters down, so you can get your horizontal line. So with that 9 centimeters, it will contain the plan. Then the lower part also will contain what we have there. We have that. Say from your borderline, 9 centimeters down from the 2 points. From your borderline, 9 centimeters down, at the other side also, 9 centimeters down. Use your T-square, get it horizontally. So that's the first horizontal line. You know that line will be print line, not thick line. Have we done that? Extend that line as long as possible. Assume this board is my own drawing sheet. Let it be like that. That's from left all the way to your right. In fact, let it touch the borderline. So it's a straight line. Draw it as long as possible. It's a T-square. Then also for the vertical one, the distance is 76 for the, now, remember that we said our side view will be to position to our right. Our side view is to the right. That means the front and the plan. The front and the plan will be here. And the side view will be where? Will be here. Front and the plan, here, here, the side view here. The other line will be like this. So horizontally, 205 is for the front, 205. So let's add 1. That's 215. So 21.5. So horizontally, mark 21.5 from down, mark 21.5 from up of the borderline. Join them together as straight line. So that this place will contain the 2, and this place will contain the side. So we got the horizontal line. I said for the front view, our plan will be up here, front will be here, side will be here. The total length of the front view and the plan is 205. We add 1 to it, 10 to it, that's 215, 21.5. From down here, mark 21.5. From up of the borderline, 21.5. Join it straight line. Now take your protractor. You know your 45 will be upward here. Get your protractor here. Your protractor on the line at the intersection. Make sure it's on the line, then you mark 45 degree upward. Then you mark 45 degree upward. After getting these lines, we continue with the normal step. So which is to get our marginal lines. Now, please don't use 1 centimeter. We don't have space. We don't have space. Don't use 1 centimeter. Use 0.5. In fact, you know I normally use 0.5. The essence of the margin is to get a margin between the front, the side, and the plan. If you go ahead to use 1 for this place, your paper will not contain it. It might, but you don't need. So what I will do is this 0.5, just for the left hand side. Mark 0.5 or 0.5. Then come to the right hand side also with your ruler. Mark 0.5 or 0.5 down. You join the two horizontally. All these lines are straight lines. So you join them horizontally. Then this also the same way. Then you do the same for the vertical. From up also 0.5 left and right. From down 0.5 left and right. You also do the same. So that the margin itself is 1 centimeter. The margin width itself is 1 centimeter. So that gives us the line. Then from there you can start the drawing with the given sketch. So we are going to start with the fonts. Yeah, we start with fonts. So that our fonts can give us our plan. First, we got the fonts in the plan to the side. So font first. Alright, so we go on to now. Okay? So if you are there now, the font view, the total is 36.5. So we are going to mark that first. Total is 30.5. So we are going to mark that 20.5 at first. So from down, don't forget, all these lines are fixed lines. From any point downwards, mark 20.5 to the left. It should be almost to the borderline, but there will just be a 5 millimeter difference. Like from the same line also 20.5, join it together with your T-square or your number as a straight line. 20.5. So horizontally, you mark out 20.5. From the original line, this last line. From this line, from here, mark 20.5 to your left, mark 20.5 to your left. Join it together as straight line. So 20.5 to your left. first one of 20.5 to the next. The midpoint there, as you can see there, you have the function of 25. You have 180.25, right? So now we shall take 2.5 from the right to the left. 2.5 from the right to your left. This is what I'm doing. From this same point, from this same line, so you have to be here. From this same line, 2.5. From this same line, 2.5. Join together, 8 line. 2.5 to your left. So that we can use it for the midpoint of that circular part. Let's see which other dimension can we take. Let's go for this. Let's look at all the passes before we take the horizontal. Now, you can see that from the left-hand side of our plan, we have the total distance of 64 from up there. Total distance of 64. After 64, 12. After 12, 25. You can see those three. 64, 12, 25. So we are going to get it from the left, from the last line to your left. So you will get 18 words. 64, 12, and 25. So it's easier when you get all your lines that are given before you now start getting what you need. So we get all the patterns, we get all the horizontal before you now start doing the calculation. So 64, 12, and 25. That's the next thing. So from the left-hand side, from here, you know you have a line here, that's 20.5. After the other line, you have one other line here, the first line. So you are firstly going to mark 64. So at any point on the line, make sure you look at the horizontal. So you mark 6.4. Then from this 6.4, you mark 1.2. Then from the same 1.2, we mark 2.5. 6.4, 1.2, and 2.5. Do the same thing downwards. From any point of the line downwards, mark 6.4, 1.2, and 2.5. That means from each of them. When you get to 6.4, put it at the point of 6.4, get to 1.2. At the point of 1.2, get 2.5. Then you join together, complete line. You join together as this line also. 6.4, 1.2, 2.5. So 6.4, 1.2, and 2.5. This place. Right? 50. Once you get all the lines that are in, you still come back to this one. So 50 from here, that's 5.0. But you already have 2.5, right? Half of 50 is 25. So add another 25 to it. From this 2.5 that you got here, you get another 2.5. From this 2.5, you get another 2.5. Then join it together next time. From that 2.5 you've gotten, get another 2.5 inwards. That's another 2.5 to your left. Then join together. From that 2.5, another 2.5 to your left. Then join together. Which of them contains ingredients? Let me tell you, it's going to have 1, 2, 3, 4, 5, 6. It's going to have